Um, B is 4 over 3 pi r cubed. So dV would be 4 pi r squared dr. 82. B equals pi r squared h. And so dV will be pi r squared dh. The r is 2. The r is 2. The height is 3. And then it's not relevant though. And then 3.05. So that would be pi times r squared, 2 squared, 4 times 0.05. So that's pi over 5. Yeah, okay. So let's check those answers if we can. 79, 12x dx, 81, 4 pi r squared dr. Yeah. Okay. Now, for the following exercise, use differentials to estimate the maximum and relative error when computing the surface area or volume. Where's 83? Did I skip it? Oh, I did skip 83. 83. dV. Okay, so dV will be 2 pi r h dr. So that would be 2 times pi times the radius times the height times d height with dh, which is negative. So that would be minus 6 over 5 pi. Yeah. Yeah, okay. 84. A spherical golf ball is measured to have a radius of 5 millimeters with a possible measurement error of 0.1. What is the possible change in the volume? So the dV is 4 pi r squared dr. So that would be plus or minus 4 pi r squared dr. So that's plus or minus 10 pi. Well, just say plus for the maximum and relative. Okay, so that's the error. And then the relative error would be, I think, that over the original volume. So that's 10 pi over 4 over 3 pi r cubed. That's 3 over 50 millimeters. 6%. I don't know if I've done that right. I'll have to check with 85. A pool has a rectangular base of 10 by 20 and depth of 6. What is the change in volume if you only fill it up to... Okay, so volume is x, y, z. If we take z as the height, maybe x, y, h. So dV is x, y, dh. So that would be 10 by 20 by 0.5. That's 100 feet cubed divided by the original, 10 by 20 by 6. So that would be the error, and then the relative error would be as a percentage, 8.3% recurrent. 85 minus 100. Where's the relative one? For the following exercise, use differential to estimate the maximum and relative error. Oh, actually, 85 wasn't. That's weird. 85 is quite different. Actually, I got confused because I don't think this instruction applies anymore. It's just a regular question like before. That's kind of weird. That's why, yeah, okay. I think this, I think I might open a ticket about that because that instruction before 84 only applies to 84 because now 85 and 86, they don't answer the error. Let's say, yeah. A pool has, yeah. Okay. 86. An ice cream cone. An ice cream cone has a height of 4 and radius of 1. If the cone is 0.1 thick, what is the difference between the volume of the cone, including the shell, and the volume of the ice cream you can fit inside the shell? Okay, so I guess you can call that a dB. So that would be 1/3 pi r squared h. But what's difference is the thickness. So yeah, minus 1/3 pi r squared h. So if we picture the cone, um, the difference would be there's a little bit of a difference in the radius, but also the height. But I doubt we are needing to consider two variables for this question. Um, yeah. Mm, 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 mm. Yeah. The pity does not answer at the back for this one. Ice cream cone, height 4 and radius 1. Yeah, okay. 1/3 pi pi the height, what's the height? 4 and then 1 squared minus 0.9 squared. 19/75 pi, 0.7958, etc. inches cubed. Okay. Pity there's no answer at the back for that. All right, okay. 87. For the following exercise, confirm the approximation by using the linear approximation at x is 0. All right. So root 1 minus x, that would roughly equal f of 0, which is 1. plus the derivative times x minus 0. And the derivative is bring down the power, reduce the power by 1, and multiply by the inside derivative. So that would equal 1 minus a half x. Yep. 88. 1 over root 1 minus x squared. 1 plus the derivative times x minus 0. Bring down the power, reduce the power by 1, and multiply by the inside derivative. Oh, and that's a 0 I meant to say, not an x. So it's just 1. 89 root c squared plus x squared equals f of 0 plus the derivative times x minus 0. Bring down the power, reduce the power by 1, and then multiply by the inside derivative, which would be 2x, where the x now is 0. So that makes that gone, and that will equal c. And that is the end of 4.2, it looks like. I think I will open a ticket about that question, though. I think I will submit a ticket about that. Okay, excellent. 4.2 is complete. How are we for time? Only 13 minutes. Not bad at all. Thanks for watching.